Hi, everyone. So I'm going to be presenting my experience on how I implemented astronomy as its own subject for Guatemalan secondary level students. And this is the outline of my talk. I will be talking about the current state of astronomy education in Guatemala. Then I'm going to show you a bit about the program proposal I made for high school students. I'm going to talk about the backup I had for administration accepting my program as astronomy being taught as a separate subject in high school. That was a phenomenological research I did in which I proved that students wanted to learn astronomy. After that, I'm going to give you some of the successful practices I've found throughout the last 4 years that I've been teaching the subject, and some recommendations if you want to do a similar process in the country you're currently working in, and if you want to implement astronomy as well in the school you're working at. So basically, the current state of astronomy education in Guatemala is that it does not have an official astronomy subject in its curriculum, like many other Latin American countries. Astronomy topics are taught, though, as part of the science courses during primary education stage, which here is the equivalent of students of ages 7 through 13 years old. And the contents that have been taught focus mainly on the sun, earth, moon system, the lunar phases, eclipses, the solar system, and cosmological theories like the Big Bang and the Mayan theories for the origin of the universe. So as you can see, it's very little astronomical content that they have as part of their science courses. And it's also important to mention that astronomy it's basically the last unit in which throughout the school year. So a lot of teachers that are rushing to cover the whole curriculum don't normally have time to dedicate just for astronomy in that part. So it's also something that is left out in some school years. So for my proposal, what I did was do actually a state of the art. This was my dissertation for my bachelor's degree. So I started off by doing a state of the art on how astronomy is being taught in other Latin American countries around the world. So the idea was to see what has been taught in countries in which astronomy is already its own subject, like Chile or Uruguay. So I went through all of their curriculums and I adapted it to something that would be better fitted to a Guatemalan society. So I use a program proposal that includes 5 units. And these units are I work with standards in each of these units, and I'm going to give you an overview of what these 5 units include. So the first one is Introduction, Constellations, and Observational Astronomy. In this unit, the idea is for students to locate the position of objects in the sky during daytime and nighttime in their daily lives. After that, we have a brief history of the universe from the Big Bang to the modern era. So in this case, the idea is that we go from all of the evidence that supports the Big Bang theory. Then we go to the formation of the Milky Way, the formation of our solar system, how this is evidence in the elements that surround us. And then we go through a short overview of astronomical history and important characters that have developed the science throughout the years, like Kepler, Galileo, Newton, the Harvard computers, for example, Vera Rubin, etc. And the idea is for students to relate this evidence to their microscopic and macroscopic context. Then we have the Earth, the Moon, and their motions. So the idea is for students to predict changes in celestial bodies' appearance based on their geographical position, current date. After this, we have the last 2 units, which is the solar system, and we have the standards, which is students recognizing the unique environmental astronomical characteristics of the Earth in comparison to other planets in the solar system, and also interstellar space, stars, galaxies, and nebulae. So the idea is for students to relate here astronomical observations and available data to the study of interstellar events. So here there is a lot of citizen science websites I use for students to analyze current data. I included two options in my program. One is for this to be included as a content unit in science courses throughout the whole high school education, something similar to what has been done in primary education. The idea is for one unit to be taught each of the years, or for it to be a formal subject in high school, which is what I'm working on in my current experience as a full-time astronomy teacher. So how did I get admin to listen? First of all, I did a trial program. I'm going to show you in a bit what I did to back up why I wanted to implement this trial program. And I wanted to show you the progress I've had throughout the years. So first we had students doing class presentations, and it was basically working with the material we already had. But after years of implementing it, we have administration dedicating some of the school's budget to actually buying telescopes so I can do daytime observations with the students and actually do hands-on projects. So I did a phenomenological research in which I gave the students 3 talks. This was all done before I showed admin my proposal. I gave them 3 talks on a math topic, a physics topic, and an astronomy topic. I recorded those talks. I looked through the students' behavior and observed if they were distracted, if they were more engaged, and if they made questions, etc. And after this, I also did focus groups in which I asked the students what they thought in the moment I said that the talk that day, it was the last of the talks, was going to be about astronomy. So these are the comments that they gave during those focus groups. And I want to focus on the last one, which was from a 12th grader, in which he said that astronomy should be a topic, a subject that is taught since we're little. It should be a class that everybody has to take. So this is part of the evidence that got admin to say yes. It's students, it's coming from students. It's students that want astronomy as a formal subject, and they're asking for it. So after I presented this, I also had this part in which you could actually stop the video and go through this a bit more carefully. But here is where I qualitatively analyze the students' behavior and see if they were distracted or bored. And distractions are in yellow, in purple and lilac. And you can clearly see that when the astronomy talk, which is the third one, was given to the students, that's when they were more engaged and less distracted. All of this research was showed to admin, and they gave me the chance to implement astronomy as its own topic. So once I had their good to go, I started implementing it as its own subject in high school for the last 2 years. Basically the last 2 years they have before going off to college education. So they chose astronomy as one of their elective courses. I started off with a population of 75 units, 75 students the first year I started with the course. And now I have 115 students who choose astronomy as one of their elective courses. It's important to say that the students are from 16 to 18 years old. The course started off in virtual education, and the students that are taking this course are surrounded by technology everywhere. The school permits the use of devices and encourages it. So how have I engaged my students with them having technology all around them? I've found successful practices in digital tools like Stellarium, Zooniverse for citizen science, Star in a Box is amazing, and also social media as a way of students evidencing their knowledge is a great way to have them engaged. So I've used TikTok and Instagram for them presenting projects, like for them doing scientific outreach with correct information. So stuff like the Big Bang, you can clearly see that there's also Instagram profiles that have been done. And I've also had some project ideas that I've done with students. We have TikToks that show their solar system to scale, which is the one that you saw here before. This is a TikTok that they made. Role-playing, comic books, etc., and board games about stellar evolution. So Students and young adults are impressively creative when it comes to creating digital content, and they also still enjoy hands-on activities. So disconnecting them from the devices, doing exactly the opposite, it's something that is refreshing for them and has them highly engaged. And you can see them here in some board games that the students did on stellar evolution, in which they had to complete tasks like analyzing stellar spectra, seeing the next path in their evolution, depending on the mass of a star, etc. The last slide I have is on recommendations for teachers that are trying to do something similar in their country. So start by taking examples from astronomy curriculum in a similar context, like what I did for Latin American countries. The second part is that administration listens to students and families. So if you have their support and you can evidence it via surveys or focus groups, there are more chances that the course is going to be approved. The third one is something I found crucial. Have your program proposal ready as soon as possible, because the moment that admin gives you that yes, gives you that good to go, they're going to want to implement it immediately. So if you have it already, that's when you normally have a good response from administration. And the last one is to basically have fun with it. Be flexible, listen to students. There are different ways for them to present their knowledge, and it's a wonderful course to teach once you have that approval from administration. So thank you for your attention. Please write if you have questions on more of the research, the previous research I did, or my experience with administration. And I hope you enjoy the rest of the workshop. Thank you.